Hi, in this video today I'm going to show how to use the finite element solver called Femwell, which is an open source mode solver used together with GDSFactory. So Femwell is a multi-physics solver that can solve things like heat as well as electromagnetic modes in waveguides. If you want to learn how this mode solver works, you can go to the GDSFactory.com website and then click on GDSFactory Plus. Once you do that, you will see we have a reference guide here on how to do models. So this is a way to create compact models. So we will have some models of how photonic stacks are defined and how to simulate electromagnetic modes. In this tutorial today, we're going to change the waveguide width as a function of the waveguide width. We're going to simulate the electromagnetic modes that are supported in the waveguides. You can also do other things like waveguide dispersion, as well as calculating the mode in waveguide bands, as well as coupled waveguides. This is for evanescent couplers. We will do other workshops later about thermal heaters where we can define things as trenches. So if you want to get started, another thing you can do is that you go to gdsfactory.com, go GDSFactory Plus, and then it's part of the quick start guide. We have here a workshop. So as part of the workshop, you can do it. So we have two types of workshop. We have the cornerstone workshop, which is one of the PDKs. But in this case, we're going to do this epic e-beam workshop, which has also similar contents. So this will also use, instead of using cornerstone as the foundry, we will be using the foundry from SciEpic from the EDX course. So what I'm going to do, I'm going to go to the workshop credentials. I'm going to click this link. I'm already signed in, but I'm going to log out so you see the same thing. So I'm going to use this user, let's log in, and I'm going to use this password as a way to log in. Once you log in, the most important is to go to these cloud workspaces, and I'm going to create my own cloud workspaces. So for example, I created one 6 minutes ago, I created one day ago. Usually it's nice to delete the ones you're not using, so I can delete those ones. But I'm going to click new workspace to show you how you can create your own workspace. So in this case, I'm going to create my own workspace called Joaquin. Just call it Joaquin mattress, and I'm going to use as a template, not the cornerstone, but the one from SciEpic, which is going to be the one I'm going to be using for the workshop. So once you click on this, you will be able to start. It will take 2 minutes to start because this is starting a new computer for you. And now I can click on the link that I just created 7 minutes ago, so you guys can see the same thing that you will see when you create a new one from scratch. So this will have most of the layout part that you will be doing. It's on the GDSFactory Plus tab. For example, like you can see examples of these PDK components, but you can also create your own components. For example, I have here a few examples on how to make your own chip, like 1, 2, 3, and 4. So you can see all the layout, and then you can click on the pencil to see the source code as well. But for today, for the simulation of the modes, I'm gonna go in the files, and I'm gonna go in the notebooks, and then I'm gonna go to the GDSFactory training. So we have two types of training. So let's calculate the mode of a single waveguide. So this is the mode solver FEM. And I'm just going to run this cell. So I'm going to use the default virtual environment, and I just pressing Shift Enter, or you can also click on the play button. So when you click on the play button, it runs every of the cells. I usually like Shift Enter because that way I can just keep clicking Shift Enter. And this is going to calculate the modes of a waveguide where you have things like the sidewall angle. And I'm going to calculate the modes, like this is, for example, the T fraction, and then you can do things like the fields for different modes and calculate different properties of the modes. Another interesting notebook is a notebook where we're going to change the width of the waveguide and see which modes are supported. And you can do this thing in different materials. For example, you can do these things on silicon nitride, where you have a waveguide of 330 nanometer, and then you can change the waveguide width and see which modes are supported. Or we can do that with silicon, because silicon has higher index, it will have slightly different modes that are supported for different widths. And you can see it's pretty fast to calculate the modes. And yeah, you can see when it's finished, I can plot all the modes, and I can see the single mode conditions. You can see the T are pink, so the T0 is this one. T1 starts to be, the second order mode starts to be supported after 1 micron. And for silicon, this is going to be slightly different. So when you do silicon waveguide, so the silicon material, the refractive index is 3.47. So this is more representative to the one you're going to be fabricating in the EDX course. And as I change the width of the waveguide, I will be supporting different modes. So in this case, once this reaches 100, I will be able to see the mode supported for silicon. So I can see for silicon, the T0 is always supported. T1 will be supported after 450 nanometers. It's roughly like 500. That's what the waveguides in this course are using 500, which is the on the limit of single mode condition. Thanks for watching and good luck with your experimentation.